Thank you everybody for coming along to my talk. This is a hardware hacking talk, not doing anything with the software reverse engineering. It says on the box everything's housed in China, so there's no need to actually do that. If anybody was at the training for reverse engineering, you should be able to play along at home with this one. So, chapter 1, once upon a time. My mother went overseas, and so she bought this little camera. They're very cheap to plug in so I could keep an eye on her house. And when she was finished, of course, we immediately unplugged this thing because it's something you don't really want to have running all the time when you're at home. So I took it home with me, and as with most items, as soon as they hit my workbench, they fall apart. I don't know what it is, it's just something that happens. Every time something touches them, my wife's like, do not put that on the bench, it will fall apart. So the very first thing that you do is go through and do a bit of reconnaissance. So the idea is just to try and identify what's inside it, have a look through, try to identify what each chip does and how it's kind of laid together. You know, and a lot of the stuff is actually really quite cool because it's cheap. Like this is a $30 camera. But the actual construction inside it is actually really, really good. So it's quite a neat little item. So once I've gone through and identified what each chip is, or just get the number off them, and with my eyes nowadays, let's take a photo of it and zoom up the photo so we can actually read what's on there. The next thing you're going to do is you're going to go out and find your data sheets. The data sheets are gold. They tell you all the information about each chip, what it does, how it works, what it does inside, and you know, it's quite surprising for such a small little chip. It's actually got quite a bit of functionality inside there. So it gives us an idea there that this particular main SOC processor, which is a system on a chip SOC, it's designed specially for cameras. So it has all the stuff built into it, like the motor drives, so the camera can turn around and all the bits and pieces like that, and audio built in. The other thing that it has in there is the pinouts, and the pinouts are really, really handy because like this particular chip, I think it's got something like 88 pins. So trying to go through and figure out which one each one does would take forever. So use your data sheet, figure it out, and as you can see on the other side there, it's got little arrows to where the pins are. You can also see the larger circles there. So usually these are pads that you can use to talk to the chip. So what we're going to do here eventually is talk to the chip and find out what's happening inside it. The trouble is when I used the meter to try and figure out which pin is which, they didn't work, they were dead. So it was like, okay, there's obviously something missing, and this is quite common where they'll actually remove components off a board just to stop people like me from playing in there. So of course, if anybody that knows me, there's always an X-ray involved. So it's upgraded this year. Last time it was an old dental X-ray that was really scary, and we had to stand in another room and cover ourselves and push the button, where this one we could actually sit outside it. It's good. But as you can see on the side there, I put the red line where the tracks run, and as you can see it disappears and there's just a components missing. These components are like smaller than a grain of rice, so again, my eyes, I ain't going to be able to put them back on there. It would just take far too long. So I use a pin board. So this is a really cool little device. It just allows you to hold the magic blue tack, holds the board down, and then put these pins on each individual piece. These things are really sharp. I've still got a sore finger from actually stabbing myself with this. But it allows me to go directly onto the individual pins, and that way we can kind of start to work our way through. So from here, we'll plug it into the computer through a serial converter and see what's actually on the screen. So this is kind of, you know, basically we're in. You know, this is in the movies, you know, the TV show where they tap, 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 we're in the FBI already. So cool, yeah. Here's the display. So this is what's called a UART output. So you might hear UART, TTL, and serial. They're all basically the same. There's slight differences, but they're all basically the same. But this is actually what's happening when the camera boots up, when the processor actually starts to run. And it gives you a lot of really cool information about who made it, what sort of chips inside there. Some really important information about how the memory layout is actually inside the chip it's using, so it knows where it's going. Unfortunately, we kind of get to the bottom and then it asks me to log in. So I spent ages here trying all different combinations, root, password, all that sort of thing. So after a while, I'm kind of lazy, so I thought I'm not going to spend time trying to reverse engineer what this is. So let's try something slightly different. As with most things, I don't try and do it because I thought it was hard. I thought this was going to be easy, and it turned out it kind of wasn't. So part of the looking at the board, one of the things we found is the flash chip. Now, think of the flash as a hard drive. So this is exactly the same as the SSD or the hard drive that's in your laptop. And it holds all the data. So when the main processor starts up, it drags the data, the boot sector across, and it starts to boot up. So what we're going to do is I need to take this off the board and actually start to copy all the data off it. So what I actually did was remove the board. So as you can see, it's soldered down. This is something that you can't just pop off without destroying something. So you've got to heat it up to quite a high temperature to remove the chip. And then what I did is put it onto one of these little holders, which is on the bottom right there. Two reasons mainly. One is I don't have a very expensive reader that I can put that chip directly into. I have a little cheap-ass Chinese one there, so it can only take something that's got pins. The other reason is by taking this off and on, and I'm going to be taking it off and on the board regularly as I try different things, you've got to put a lot of heat. Now, there's a couple of 100 degrees that's going to be put onto the board. So it's very easy to damage the board or damage the other components, or even, as you can see, the tiny little squares and everything like that, resistors and capacitors, the solder's going to melt on those as well. So a nudge, a touch, anything that falls off, you've kind of had it. So in the end, pull the chip off, put it in the reader, downloaded the flash, and this is kind of what you end up with. So it's all represented here in hex. So it's a huge file with all this data. So there's an 8 meg file in IoT, that's a huge file. And it's all just hex. So there's nothing much you can really easily look at. Sometimes the beginning of it might say, if it's encrypted, it might tell you what the encryption is, but in general, there's no way that someone like me is actually going to go through and try and figure out what's there. But there's some really cool tools. So one of the earlier talks yesterday was talking about binwalk. So binwalk's a really neat tool, and what it does is it takes the flash and it tries to figure out what's in there. So this is like the partition table. So again, back to the hard drive analogy, this is the partition table for that flash. And the one that we're really interested in is the last couple there, which is the Squash FS. Squash FS is really common on IoT devices, again, because it is quite small. The other thing to remember with Squash FS is it is actually read-only usually as well. So it does mean that you kind of, when you pull everything off, if you're in the command prompt, you can't really change anything. If you manage to do so, next time it reboots, it just goes back to how it was before. So as I said, we identify where they are. The big things to kind of remember here with is those decimal numbers. When the chip first boots up, it has like a boot partition, and those numbers, which are locations inside the file, are where everything has to be. So if you change any of this and swap things around, it's not going to boot because the chip's going to be looking at this particular location, and if what it's looking for is there, isn't there, sorry, it just won't work. So things are starting to get serious here because now I've kind of got this flash, but again, we have to try and figure out what we're going to do with it. So what we can do is we can actually pull it apart because it is just one big file. So there's a DD command, which is an old DOS command, which allows you to copy sections of files. And this doesn't necessarily need to be flash. It could be a picture. It could be anything. And so all I'm really doing is telling it to skip forward to the first Squash FS partition and then just copy that little bit out. And then as a double check, I just run it back to binwalk again, and it says, yeah, you've got it. So if it come back and said it couldn't recognise the new file that I've created, I've got the numbers wrong. And then because it's a Squash FS, you have to unsquash FS it. So what this does is it just turns it back into a file system. So when we pulled apart with DD, it is still just hex. If you open it up again in the hex editor, there's nothing in there that's readable. But the unsquash FS will then turn it back into a proper Linux style file system. So on the right there you can see that that's the file system that gets created out of there. So anybody that's familiar with Linux, you can start to move around there, look what's going on, try and figure out what apps are there. My main thing was I wanted to actually get root access. So there's a few ways to do it. You can remove the root password, you can do all sorts of other things. I checked a file called the init tab file. So the init tab file is there. It tells Linux what to do when it starts up. So as you can see the line there, TTY, again, same as UART, same as serial. It runs a file called bin login, and that's the bit that's stopping me from, that's asking me to log in, and I don't know what that password is. So I just change it to bin ash, which is another file system. So I was like, oh, this is cool. I could just change that over, and then what I've got to do is put it all back together again. Excuse me a sec. So what we're going to do to put it back together again is, like I said, we had to have everything in exactly the same places. So I just take the first part of the original flash, take the last bit, and the centre bit there, because I've changed it, it's now smaller. So I kind of just pad it out with a few zeros, glue it all back together. And is it going to work this time? Chip back on the board, boot it up, and yeah, we're in, we've got root. So as soon as we go in there, we can... So now that we're inside this thing, we can actually start to poke around a little bit more, because there's, even though we can just look at the file system, it's actually nice to see what's actually running. So left-hand side there, you see the PS, which is all the processes that are running. And there's quite a few. This camera, I'd done a factory reset, so it wasn't going to do anything. It wasn't going to connect to my Wi-Fi. It was just sitting there waiting to be set up. So we've got all these programs on there. Let's do a little bit of living off the land. Let's see what we can actually do with this outside of what it was intended to do. So the first thing I want to talk about is BusyBox. BusyBox is an application, and what it's done is it's taken about 400 Linux little utilities, just the small utilities, and normally each one's an individual file on the file system. It puts it into one big executable, and this saves space because every file then no longer has to have the header and everything like that, because it's just one for the whole of BusyBox. And it's a really common thing again on IoT devices. The other good thing with BusyBox is you can turn around and say, hey, I only want these, say, 10 commands. And so you can remove everything else, so it makes it very, very small, and also limits what people like me can do as well once they get on board. One of the things, though, that with BusyBox that you kind of don't know is you can actually just copy another one on there, and everything goes back to how it was. So luckily this thing has a little SD card there, so now we've got root access. We can mount the SD card with a new version of BusyBox on there, and suddenly we have all 400 commands back again that the original manufacturer decided to remove for us. So this gives us a hell of a lot more leeway to try and run other applications rather than using just the versions they've got there. So what we got here, so just looking through the PS there, we've got a remote access, so that's Telnet. Never used Telnet, it's a horrible thing. It's got a little web server on there, it's got a Wi-Fi client, which is neat. DHCP server, because the idea is when you connect to it, it's going to give you an IP address. And it's actually got a Wi-Fi access point as well, which is part of the setup. So I thought, well, what are these cool things? We could have a little play and see what we can do with this. So let's see what else this thing can do. So one of the first things I looked at is it actually has a USB hub built in. So a little bit of wiring, and I can plug a USB Ethernet adapter into this thing, and suddenly it's got Ethernet, which it never used to have before, because as soon as you plug it in, the machine goes, ooh, I know what you are. And suddenly I have Ethernet, so instead of Wi-Fi, I've now got Ethernet. So you start to play with these little devices that you can plug in. It is only USB 2. I did try and put like a HDMI adapter in there, and it just said no. So what else? Wi-Fi. So it's got a Wi-Fi on there, so I can create my own host ADP config. So host AP is basically an application that will let you create an access point the same as your Wi-Fi at home. So I created my own config file and started up, and then suddenly, I've got my own access to this device now, not going through the applications that are built into the box. So the applications that are built into the box obviously we're going to say, here's this guy's SSID, and here's his password, send it off to someone else, whoever it is. So I didn't want to be able to connect to it in that manner, so I thought, well, I'll just create my own. So if anybody understands the too many secrets things, that's good. So what now? I kind of started to run out of ideas at this point, and then I thought, well, I've got no screen. I've got no keyboard. I've got access though, and I've got a full version of the BusyBox. So we do have a proper web server, and we do have Wi-Fi. And hopefully this runs. So So I must be quite honest though, the browser is doing the heavy lifting. If I had got the HDMI connection on there, that would have been doing it, the actual unit would have been doing the heavy lifting because it's capable of doing so. So that was kind of a to be continued for me. So what I want to do next is start to move on to the software side, because I didn't really go down the software reverse engineering route because I know it's sending everything back to China. It actually says it on the box. But there's been a lot of other people that have done work, especially on this particular camera, mainly because it is so cheap. So that's the next thing, is to start to pull apart the actual firmware, because I've now actually got the complete firmware, all the executables, all the things like the telemetry application and the IoT application. There's also, by having the flash, as you remember, if you remember the first one, there's a whole lot of certificates that are already in there, so we can use those certificates to pull them out and then actually try and go back up the tree into the APIs. So thank you for being at my talk today. There's one thing I just want to say too, is I'm based here in Christchurch. I am just learning this ship. It's lots of fun. But if there's anybody here that is interested in starting like a meetup or something like that for some reverse engineering, come and see me after the talk. It'll be really neat to start up. If we get a few people, we can set up a meetup. I've already got someone that we can do it. I also have quite a few friends that are very good in the electronics industry, so we can kind of get there along and they can have a talk and go through things. So yeah, if anybody's in the Christchurch area that is interested in learning some more of this stuff, it's because it's great to have more than one person. You get to bounce ideas off each other and try different things as a group and that sort of thing. So yeah, just hit me up. I'll be the guy wandering around in the strange t-shirts. All right, thank you.
I am a super genius.